Day 3 will really focus on graphing piecewise functions. Warm up this review. If f of x equals 3x minus 1, can you find the following? So the first is f of 4, and again, remember if it's inside the parentheses, that's the input, or x value. So when we plug in, it's 3 times 4 minus 1. 3 times 4 is 12. 12 minus 1 is 11. So we say f of 4 equals 11, or when you plug in a 4, you get 11 as the output. Let's do f of 0. Okay, so f of 0 would be 3 times 0 minus 1. 3 times 0 is 0, and so then f of 0 would be negative 1. So again, when the input is 0, or when the x value is 0, the output is negative 1. And the last one, f of negative 2. So 3 times negative 2 and it's minus 1. 3 times negative 2 is negative 6. So we have negative 6 minus 1, which is negative 7. So when the input's negative 2, the output, or y value, is negative 7. All right, so our goal today is, given a situation, can you graph a piecewise function? Investigation, how much do I pay for 4G data? Cell phone plans used to charge by number of minutes and text sent. Now most phone plans have unlimited talk and text, but offer different amounts of data at various costs. Today we'll look at some pricing structures for phone plans. So in class, I'll give you time to work through these questions and discuss. Number 1, what factors play a role in choosing a cell phone service provider and picking a plan? So, I mean, that depends on a lot of stuff. Price is probably a big one. Price and what each plan offers, maybe where you live and what's available. If you're part of a family plan, maybe what the best family plan is for you and your family. If there's any deals or promotions. So there's probably a lot that go into selecting a cell phone service provider. 2, Metro by T-Mobile offers an unlimited text and text option worth 2 gigabytes of data per month for $30. If you exceed 2 gigs, you're going to pay a rate of $10 per gig for each additional gigabyte. So it says, what would the monthly phone bill be for a person that used 1.7 gigs of data? Okay, so for that, it would just be, you're not going over, so just $30. What would the phone bill be for a person that used 3.5 gigs of data? Okay, so you're going to spend the $30 for the 2 gigs, plus we have to figure out how much we went over, and it's $10 for every gig that we went over. And so going over, we can use 2 gigs, so it'd be 3.5 minus 2. So what is that extra? What would that be? 1.5? Okay. So we'd multiply that by 10. 1.5 times 10 is 15, plus $30 would give us a total bill of $45. Okay, it says sketch a graph of monthly cost of the phone bill based on the number of gigabytes used. Okay. So this is the piecewise function. We have 2 pieces. We have how much it costs until we hit 2 gigabytes. So that was $30. Okay, so if we go from 0 to 2 gigabytes, it was $30. So flat right there. But then right there, it's going to go up to, and we just need one more point for the line. 1 point is right here. So another point for the second line would be at 3.5 gigs. It's $45. Okay, so let's plot that point. 3.5 and then 45. And then I'll just connect and extend the line because it keeps going. Okay, so there's the piecewise function. There's 2 different pieces. So we're going to write a rule that gives the monthly cost of using X gigs of data. Okay, so the monthly rule would look something like this. The cost for a certain number of minutes. Okay, so it was 30. I want to do that in the color that we graphed it in. Okay, so it's 30 if x is less than or equal to 2. But then if it was greater than 2, it was 30 plus how much over that we went times 1.5. So 1.5 times how much over 2 gigs that we went. So the number of hours, oh no, it wasn't 1.5. That was how much we went over. It was $10 for every gig that we go over. So I have to change this. So then it was $10 for every gig that we went over. And we only could go over 2. So that's kind of what we plugged in here. We went over 3.5. We subtract 2 the amount that we are paying the $30 for, and that's for when x is greater than 2. Okay, so again, this is x is the amount. Okay. So, I mean, that's our goal is graphing it. So we were able to do it with the word problem and also write the piecewise function. Can we graph it if the piecewise function is given? Okay, so let's take a look at this one. Graph the following function for the axes provided. Okay, so there's 2 parts to this piecewise function. Okay, so here it gives us on the interval, so the domain is -4 to 1. Let's just graph those 2 points. So I'll just make a little table for that one right there. So x is the input, f of x, or the y value is the output. Okay, so when it's -4, we're going to plug in -2 times -4 minus 2. Okay, so -2 times -4 is 8. 8 minus 2 is 6. Okay, so this will be one coordinate that we can graph. So at -4, go up to 6. And it's a closed dot because of the equal sign right here. All right, let's plug in the 1 right here. And so it'd be -2 times 1 minus 2. Okay, so that's -2 minus 2. That's -4. So here's the other point that we'll graph. And there's not an equal sign, so we'll put an open dot there. So 1 will go down to -4. 1, 2, 3, 4. Okay, so there's that first interval. We can see it's linear. There's a slope and a y-intercept. Okay, so there's that first piece of the function. Okay, and it's -5 for when x is between 1 and 4, but not including them. Okay, let's use a different color for that one. So it's just -5. Okay, for 1, -5, where's -5? Here. And again, open dot, because there's not an equal sign, up to 4. So if I asked you to find like f of 1, you would have to say it's undefined because it's not on our graph. Okay, so there's graphing a piecewise function. Let's try the next one. Again, there's 2 pieces here. Let's just use 2 different colors. Let's use pink. All right, so it's -2 when x is less than or equal to -2. So there's the equal sign. We can use the closed dot. Okay, so -2 for when x is less than or equal. Oops, there's my ruler. To -2. Okay, I'm going to find where x is -2 and go down to -2 and put a dot. Okay.
Good morning, Silver Park High School. Just a reminder, if you are parked by the field house entrance, students and staff, if you are parked by the field house entrance, we ask that you please move your vehicle to another lot. This is due to the college fair going on today. We would need that space. So if you are parked in the field house lot, please move your vehicle.
Okay, so then that was when x is less than or equal to -2. It's -2. It's 2x minus 5. Okay, so I'm going to make a table for this one. X and f of x, which is y. For when x is greater than 3. So for sure, let's plug in a 3 and solve that. So that would be 2 times 3 minus 5. 6 minus 5 is 1. Okay, so at 3, 1, we'll put a dot, but it will be open because you don't have an equal sign. And then we just need some other point greater than 3. So I'm just going to pick, 6. So any point greater than 3 we can plug in to get another point to make our line. So 2 times 6 minus 5. That's 12 minus 5, which is 7. So it's 6, 7. I'll plot a point. And I'm going to go ahead and connect that. Again, it's linear. We have a slope and a y-intercept. And that'll be a closed dot. Okay, so there's our piecewise function. So there's this interval that it's undefined for, but we have graphed the pieces of the graph provided. Okay, let's take a look at graphing this one right here. Got the following function for the x is provided. Okay, so it's x, so whatever x is, when x is less than or equal to -3. So again, let's graph that one right there, x and f of x. We just need 2 points. One of them we'll use as -3 because that's given. And it's just x, so it's -3. Okay, so, and we'll use right there an open dot because there's not equal sign. So -3, -3. Okay, so there's the open dot. And now let's pick any coordinate less than -3. So I'll just pick -5, and it just is x, so that's -5. And I'll make that a closed dot. So -5 is left 5, down 5, and that can be a closed dot. Okay, so there's the first piece of our function. Make a straight line right there. Okay, and then we have our second piece of the function. It's 5x minus 5 for when x is greater than or equal to 2. So again, we'll plug in the point provided. Okay, so here's our second function. So 2, the x value is 2, and let's plug in 5 times 2 minus 15. 10 minus 15 is -5. Okay, so at 2, -5, we'll put an open dot. And then let's just plug in something bigger than 2. So let's just plug in 4. Any number bigger will work, but okay. So 2 times 4 is 20, minus 15 is 5. So 4, 5. That little piece right there. Ooh, and let's use the straight line tool here, which is not that. Oh, I had it. Okay. Here we go. Okay. So here are the 2 different pieces for our piecewise function. There's some scratch paper here. We'll be doing it on Delta Maths, but in order to make the table to graph the coordinates, you probably want to use the scratch paper here. Remember, you'll use an open dot if you don't see an equal sign, and you need at least 2 points to graph a line. Okay, so do day 3 graphing piecewise functions for tomorrow.